So it's looking good. We've got a digital signature, we've got a decentralized ledger, everyone's got a copy, it's online, fantastic. What else can go wrong? What about Dodgy Dave? You see, that's our next problem. The scoundrel in the group. He's worked something out. He's understood the decentralized document. He's actually got his head around the concept of digital signatures that are a function of the message itself. So now he can't delete the document because everyone's got a copy which updates in real time. He can't falsify signatures because the signatures are now smart and they're context-specific signatures. But Dave has recognized that there's a loophole because he's realized he doesn't actually need to create a new transaction and falsify a signature as such, because what he could do is just replicate entire transactions with the signature again and again. So let's say Dave thinks, I've got a transaction that says Dave paid Sally £10. Well, that would be a real transaction. The system so far would allow it because the digital signature, haven't noticed any changes, is a proper transaction. The digital signatures are a proper function of the body of the message and it would be verified. The ledger would show that Sally owes Dave £10. That makes sense. But Dave thinks, what if I just replicated the entire transaction again and again? Well, then the ledger would show 3 legitimate transactions because this digital signature hasn't rung up any alarm bells. As long as they were scattered here and there, no one's going to check at those weird digital signatures. The ledger would show that instead of Sally owing Dave £10, Sally now owes Dave £30. Ooh. So there is a problem with this system, that what if you replicate the entire message along with the digital signature? So the next step is to make sure that the same message can't be duplicated again and again for fraudulent purposes. Satoshi Nakamoto realized that this was a problem with electronic currencies, just like counterfeiting. This was called double spending, the problem of the double spend. And the way they overcame this problem was to make sure that each transaction has its own unique identifier as well. And the identifier would be a timestamp. So then you could create a random number as a function of both the message and the timestamp as well. Then you would have complete immutability. This idea of data that is unique and cannot be tampered with. So now we have an online digital signature, an online digital ledger. It's decentralized in a way that allows it to be viewed in real time, and whenever all the transactions are updated, there's an encrypted digital signature that morphs continually so that it can't be copied. The digital signature is not only a function of the message, it is also a function of the time of the transaction. So we have overcome the problem of double spending. We have achieved immutability. This means that once any transaction is carried out and verified on the blockchain, it can never be denied, backtracked, or modified. And that is what every cryptocurrency would need to achieve before it becomes viable. Now we're getting there.